Assalamu alaikum, everyone. For those of you who may not know, this is a Muslim greeting which means peace and blessings of God be on you. It's simply another way to say hello. Thank you so much for giving us an opportunity to talk to you today. This year, we are going to talk to you about astronomy. Astronomy is a study of what surrounds our planet Earth. That is space, planets, stars, and much more. Today, we use very powerful telescopes to look into distant space and observe far-off stars and galaxies. Whenever someone looks up at the night sky, they're looking billions of years back in time. The reason is because these stars that we see are really far away, and it takes so many years for the light to travel to us from them. We are now going to show you a trip we took to countryside to look at the beautiful night sky and gaze at the moon and the stars. We encourage you to do the same with your families.
दीन अहमद का जो आज सालार है तीर हाथों में उसके
1, 2, 3 अस्सलाम वालेकुम वालेकुम सलाम everyone
है इब्न मंसूर की एक ललकार है दीन अहमद का जो आज सालार है तीर हाथों में उसके न तलवार है
Science about things out of Earth's atmosphere.
That's right. And what is outside of the Earth's atmosphere? What are things that are outside of the Earth's atmosphere? Summer.
Stars and planets.
Planets. Go ahead, Urva.
The galaxy.
The galaxy.
दीन अहमद का जो आज सालार है तीर हाथों में
If we see this light that's coming here, let's imagine this was the sun. Now, right now, it is almost 8 o'clock. We like the shadow to go to 8. And you place it down right there. That shows that it's 8 o'clock right now. In an hour from now, you will see, when you come and look at the sundial, if you leave it right here on this table with this light on, you will see it will be 9. The shadow will be at the 9.
दीन अहमद का जो आज सालार है तीर हाथों
Imagine these are the stars, and these here are what we're going to make the shapes out of when we join the constellations. I want each of you guys to make a constellation with the marshmallows and the toothpicks. Can you guys do that? Yeah. Okay, be creative, and maybe if you know some constellations, make them. Okay, go ahead.
दीन अहमद का जो आज सालार है तीर हाथों
Look at the moon. It looks smooth to us. It's a little crescent moon, I know, but looking at it, it looks like it's smooth. It's smooth. But when you look at it up close, it has craters. It's an impact on the moon when there's something hard or an asteroid or anything like a meteorite that comes in and it impacts the moon. It leaves a big indentation. We are going to do a demonstration on how these asteroids or meteorites hit the moon's surface. So we are going to imagine that this is the moon's surface. And I'm going to give each one of you a marble. Okay, here. Each one of you is going to get a marble. Please drop one as high as you want. See the indentation that's created a hole right in there. And you see all the minerals that have come out, and then they have showed, that's exactly what it shows on the moon. So that doesn't, you can see this one did not hit as hard. It looks like Isa's hit really hard. But that's just an example of how the indentations in the moon are.
दीन अहमद का जो आज सालार है
Do is take a step up here, and you're going to look at the moon. We're looking at a close-up of the moon. So look at look down and look at the craters on the moon. Tika? You see it? You can see the moon. You see how the surface of the moon is really rough and you see all the craters on the moon? Do you see that? And it's
Yeah,
you
I
see,
can see it.
you see it? That's the moon. That's the surface of the moon. And you see how it's not that clear because it's a crescent moon right now. Is it interesting?
Yeah.
So the surface from the moon, when you see from here, you see it's so smooth. But when you look through a telescope, you could see how rough and how many craters are on the surface. Okay, great.
I'm an astronaut, Leo.
What's an astronaut?
How do you, if an astronaut is sad, how do you make it happy?
If an astronaut is sad, how do you make it happy?
You give it some space.
Oh, I like that.
दीन अहमद का जो आज सालार है, तीर हाथों में उसके न तलवार है.
Look at any part of the sky, and this will tell you the name of the star, the constellation it's making, and everything about it. Like you can even see planets on it.
दीन अहमद का जो आज सालार है, तीर हाथों में उस.
So let us look more closely at some of the big planets in our solar system. Jenna Hines, who is an outreach coordinator at the Royal Astronomical Society of Canada, will walk us through her telescope images of these planets.
Today, I'm going to talk a little bit about some of the planets that you can see if you head outside, even this evening, depending on whether or not there are clouds. So we're going to focus on two planets today, and that's Jupiter and Saturn. Those two planets, I can't see what everyone's talking about with each other, but if you've seen them, please let us know either in chat or in to each other if you want to give each other a quick nudge if you've seen either of those planets. They're really bright planets, and they're pretty easy to see even if you live in a city. So they are up for another couple months, and I'm going to show you how you can find them by sharing my screen here and looking at our view this evening. This is from Toronto. This is our view tonight around 7 o'clock of the sky. And if you look down towards the south, you're going to be able to see two really bright objects fairly close to each other. The moon's going to be rising over here soon. And you'll also be able to see this planet here, which is not what we're going to talk about today, but that is Venus, and it's only up right before the sunset. If you look at these two bright objects, they're going to be the brightest things you can see facing south. The one on the left here is Jupiter. It's brighter of the two. And then the one on the right is Saturn. And so if you take a look for those two tonight, Saturn is quite a bit dimmer, but you'll be able to see them even if you're in a city. They're really, really bright. So even though there's lights from the city, they shine right through, and you can see them yourself. Now, normally what I would do is pull out my telescope and let you look at them. But of course it is daytime. So we can't, they're a little bit harder to find in the daytime. So what I'm going to do instead is share the views of these planets from my telescope. And so what you'll be able to see here, this is Jupiter through my scope. It's one of my favorite views through a telescope. It's really cool. I don't know if you can see here, and I'm going to zoom in a little bit. You can see this dark band right there. That dark band is one of the cloud bands on Jupiter. So Jupiter is a really big planet with a lot going on. It's the second biggest planet, it is the largest planet in our solar system, the second biggest object in our solar system. The sun is the only thing that's bigger than Jupiter. And it's also probably the oldest planet in our solar system as well, probably formed around the same time as the sun. Those cloud bands, I don't know if you know this, you probably do, one of the most important or most interesting parts of Jupiter is this spot called the Great Red Spot. And the Great Red Spot is the biggest storm in the entire solar system and also the biggest storm on Jupiter. It's huge. You can't see it in this video. It's only up every once in a while. Jupiter turns just like Earth does. But when it's up, you can see it. It is about just a little bit bigger than Earth, actually. So Earth would fit inside of this one big storm on Jupiter. It actually even used to be bigger. It used to be about 3 times the size of Earth, at least across. but it's been getting smaller and we know it's existed for at least the past 400 years or so. So it's a very long running storm and a very, very big storm. This is, as I'm sure you can tell, Saturn. Yes. There we go. Saturn, this is way, way closer up, and you'll see a clearer view in a second. There it is. This is Saturn, the planet with the rings. It is the dimmer of the two, so Jupiter's a little bit brighter, Saturn's a little bit dimmer. Part of that is that it's a little bit smaller, and the other part is that it's much further away. So Jupiter is about 5 times the distance that we are from the sun out. And then Saturn is 12 times the distance. So it's way, way, way further. But that dark spot is caused because of the light that's shining on Saturn. The sun, at this point, Saturn or we from where we're observing in the sun are quite far away from each other. And so Saturn's body, Saturn's planet, casts a shadow on the rings behind it. And so you can see that little bit of a shadow here, which to me just makes this feel so much more real. This is by far my favorite thing to observe. I'm going to wrap up because I think we're running out of time, but it is so cool. The coolest thing about this, in my opinion, is that this planet is also very, very light, which is weird. It's big, but it's quite light. So it's like picking up styrofoam almost. And if you had a giant bathtub, if you had a bathtub large enough to fit Saturn, if you threw Saturn in it, Saturn would float on the surface. That's how light it is. So I hope that by taking a look at these videos through a telescope, I hope that you're inspired to get outside and discover the night sky for yourself. Next time that you get a clear night, see if you can spot them. They're going to be to the south. If you're living in Ontario, if you face towards the lake, I say if you're living in Ontario, if you're living on the south part of Ontario, if you face towards the lake, you should be able to see these two planets.
You might be asking, what does this have to do with Islamic heritage? Well, do you know that to date, most stars get their proper names from Arabic? Very old star names originated among people who lived in the Arabian Peninsula more than 1,000 years ago. Muslim astronomers borrowed some of the names and added to the list. In fact, Muslims worked greatly in adding to the knowledge from the Greek astronomers and developed astronomy into its own science. Let us look at some of the Muslim astronomers who did this.
Known in the West as Albategnius, I, Al-Batani, wrote the Sabian Tables, which was a very influential work for centuries. My work also included the timings of the new moons, calculation of the length of the solar and sidereal year, the prediction of eclipses, and the phenomenon of parallax. I also popularized, if not discovered, the first notions of trigonometric ratios used today, and made serious alterations to Ptolemy's theories, which at the time had been used as the important discovery that the motion of the solar apogee, or the position of the sun among the stars at the time of its greatest distance from Earth, was what it had been in the time of Ptolemy. The Greek astronomer placed the sun at longitude 65 degrees, but I found it at longitude 82 degrees. This discrepancy was a distance too great to be accounted for by any inaccuracy of measurement. But today we know it is because the solar system is moving through space. Then, though, it was believed that the Earth was the center of the universe, so this conclusion could not be made.
Allow me to introduce myself. I am Nasiruddin Al-Tusi. I was born in 1201 and I lived in Iran. Some say I was one of the greatest scientists of medieval Islam. Well, there's no surprise to that, of course. Why, I was a Persian polymath, theologian, philosopher, scientist, and physician. However, I was best known as a mathematician and an astronomer. I also wrote books on the topics of math, engineering, prose, and mysticism, therefore becoming a well-published author as well. There is a crater 30 miles in the diameter named after me. I was a minister to Holy Qur'an, Ilkhanid ruler of Persia. I was put in charge of the observatory installed at Maraga by Halaku and of preparing the Ilkhanid tables and catalog of fixed stars which remained in use for several centuries throughout the world, from China to Western Europe. Even Nicholas Copernicus, the 15th century Polish astronomer, who was famous for introducing the sun-centered theory of the solar system, which marked the beginning of modern astronomy, drew inspiration from mathematical devices discovered by me and fellow Muslims before him. The only difference between the two models of the solar system was that Muslim's Earth was fixed in space, whereas his had it orbiting around the sun.
Greetings. It's a pleasure to meet you. My name is Maryam al-Ijli al-Astulabi, and I live in the 10th century. I, like my father before me, spent all my life studying astronomy and making astrolabes. But what is an astrolabe, I hear you ask? Well, think of it as a sophisticated navigation device, but like a computer. It had a wide range of uses. It could tell time during the day, tell the direction of Makkah in the east, and it could even pinpoint locations of various stars. Astronomers in particular cherished and used them extensively. For we were all fascinated by the heavens for its deep reference in the Holy Qur'an. So much so that scholars in early Muslim civilizations established astronomy as a new and exciting science in its own right. A science that could help us discover the secrets of our universe. What is clear is the ideas and technology that blossomed in my time helped shape the thinking of many that followed. Now the question is, how would one of my astrolabes look like in one of your cars?
Founder of Indology, father of comparative religion, father of modern geodesy, and first anthropologist. Who do all these titles belong to? Well, me. I am al-Biruni, and I was born in 973 AD in Biruni, Uzbekistan. I was an Iranian scholar and polymath in the Islamic Golden Age. I have served more than 6 princes. I was very well versed in physics, mathematics, astronomy, and natural sciences. I also distinguished myself as a historian, chronologist, and linguist. I studied almost all the sciences of my day and was rewarded abundantly for my tireless research in many fields of knowledge. Royalty and other powerful elements in society funded my research and sought me with specific projects in mind. Spherical geometry was also needed when Muslims were finding the Qibla, which is the direction of Makkah, which we prayed toward and which our mosques faced. It was me who worked this out from any location on the globe. I was literally interested in everything. I sometimes got referred to as the Leonardo da Vinci of my day.
My name is Taqiyuddin. I was an Ottoman polymath born in Damascus, Syria, active in Cairo and Istanbul. I was the author of more than 90 books on a wide variety of subjects: astronomy, clocks, engineering, mathematics, mechanics, optics, and natural philosophy. I invented the steam turbine. I am best known for the Constantinople Observatory of Taqiyuddin, which I founded in 1577. I am famous for using a sextant that used the 5th type of quadrant. You could use these quadrants to align with the celestial bodies and read off the angle between a star. However, there were several Muslim astronomers other than myself who worked extensively on improving the designs of the sextants and quadrants.
दीन अहमद का जो आज सालार है तीर हाथों.
Muslim astronomers also wrote many books on astronomy. Let us now travel down to the Aga Khan Museum in Toronto to look at one such book that is more than 1,000 years old.
Good morning, Michael.
Good morning.
How's it been?
Very, very well. Very well.
Great. So
Yeah.
what do you do at the Aga Khan Museum?
Well, my role here is as curator. So I'm one of 3 curators on staff, and our ultimate goal really is to be caretakers of the collection. When we say caretakers, we mean in a physical sense, for sure, but we also mean in the sense of being able to interpret this material for audiences who come to visit us.
Okay, that's interesting. So
when you get these objects, are you the ones who date them?
The collection is actually based on the collection of Prince Sadruddin Aga Khan, who is the uncle of the current Aga Khan. Prince Sadruddin died in 2004 and left his collection as the foundational collection for the museum. When we do receive objects, when we acquire objects additionally in the museum, yes, we certainly do the research and date them and provide all of the facts about those objects. But we knew so much about the collection already when it entered, when we opened the museum in 2014.
Right.
Yeah.
Right. So, as you know, we've come here specifically to study more about astronomy-related artifacts that you might have in your collection. So, would you start us off with one and
Sure.
tell us more about it?
Absolutely.
In particular, the historical background, as well as how does that piece of work fit in and contribute towards modern astronomy?
Toward modern astronomy, great. Well, what we're looking at here is a manuscript. It's a book, and literally a manuscript means something that is handwritten. So it's a handwritten book that was produced in Iran in the 17th century, in the mid-17th century. However, the manuscript contains a text that was written in the 10th century by an astronomer, a scientist named Al-Sufi. Al-Sufi was a scientist. He was an observational astronomer, and what his goal was to observe the stars in the heavens and to calculate their positions in the sky based on old knowledge from ancient Greece, particularly from the works of Ptolemy, and to synthesize that, to link it up somehow with pre-Islamic Arabian knowledge of the stars. So there was a science or a study of the stars in pre-Islamic Arabia known as Anwa. So here we can see a copy of Al-Sufi's text, which is known as the Book of Fixed Stars. It was the text itself was written in Arabic in the 10th century, in the year 964. But it was copied many, many times and translated, in fact, many times. What we see in this particular manuscript are illustrations of a constellation that contain Arabic text near it that describe the stars, and then a Persian translation of Al-Sufi's text in the margins all around. That's the writing that you see all around. Now, you'll notice in this manuscript that each of the constellations, these are the fixed stars as opposed to the planets, which are unfixed. They move in the sky when we look at them. The fixed stars, these constellations, are shown in mirror image. You can see one on one end and one on the other. They're actually the same constellation, just oriented in opposite directions. And the reason for that is because Al-Sufi wanted he wanted his text to be a teaching tool. He wanted people to look up at the sky and see the constellations and be able to correlate it to the manuscript. At the same time that people were looking at the stars, one of the tools that they used a long time ago was something called a celestial globe, which we have an example here. It's like a globe, like we would normally be familiar with, but instead of showing the land masses of the Earth and the oceans on the surface, what it is the constellations and other heavenly bodies in the sky taken out and then wrapped around a globe form. So basically it's a mirror image of what we see in the sky. So this way, illustrated copies of Sufi's text show both what we see in the sky and what you would see on a celestial globe, the mirror image. That way it's much easier to study and make the direct correlations between the tool that you use and what you actually see in the sky. There was just a general interest in the stars and in the heavenly bodies, and really in the scientific knowledge that was initially developed in other parts of the world, like ancient Greece, ancient India, and so forth. There was a general interest in the Islamic world at this time in taking that knowledge, translating it into Arabic, and assimilating it, making it part of the broader field of knowledge that this part of the world had. And it was with this old knowledge that's then assimilated. Another thing that Al-Sufi did is calculate and discover new stars. So he recalculated the positions, he discovered new stars. There was a lot of new scientific knowledge that came with his study of old texts and with the development of his own text on the fixed stars.
Thank you for listening. We hope that you learned about astronomy and Islamic heritage today. The sky is yours to explore.
दीन अहमद का जो आज सालार है, तीर हाथों में उसके न तलवार।